So welcome once again to ANSA class. So the thing is, I'll explain you about the mouse pointer option already. I think I have did, but let me just reconfirm it. And in the last class, we have seen about the Boolean operations, right? Okay. And now
Yes.
we'll start with the mouse pointer option. See, the main thing which you will use is you can press the control button in your keyboard. Along with that, left mouse will actually try to rotate along any given axis. Okay, so you can see the three axes X, Y, and Z, right? So you can rotate about it. The same functionality will be done using the same control option with the right click. But the thing is, it rotates about only one axis. Even if you drag your mouse, it cannot rotate about any other axis. But this left mouse button can actually make it rotate about any axis. Okay, so that is the advantage. Okay, then one more thing is control plus your scroll button. If you just press and if you drag your mouse, you'll be able to pan it. And similarly, you can also, just by moving your scroll button, you can do the zoom in and zoom out option. So this you have already seen. Okay. Now the thing is, I'll explain you a few other things which I think you have also got few doubts in the previous classes. So now you have certain inbuilt views within the ANSA software itself. Like for example, let me press F1. Since I can't show you what I'm pressing out, so you have to listen it carefully. I'm just pressing F1. So it shows the side view of the entire component, right? Similarly, F1 to F6, you have all different types of orthographic views. All these are shortcuts and you cannot change these options also. These are fixed within the ANSA software itself. So if I press F2, similarly, I'm getting one option, one view. And if I press F3, I'm getting another view. If I'm pressing F4, I'm getting another view. And F5, I'm getting another view. And F6, I'm getting another view. Okay, so these are all something like the orthographic views which you might have learned in your engineering mechanics during your undergraduate program. Okay. The next thing is from F7 and F8, you have an option. See, I'm just pressing F7. It is actually zooming in, right? Now, one more time, let me press F7.
Yes.
It is again zooming in. Again F7. Okay. So similarly, if I press F8 once, I can see that it is zooming out. One more time, then one more time. So F7 and F8 are simply like your zoom in, zoom out option. I think it would be quite easy for you rather than using keyboard plus mouse pointer option. You can make use of this keyboard option itself. And all these are shortcut keys. Okay. Then we have seen up to F8. Now, let me one more time zoom this. Now, in order to fit this to screen, to your visibility, you can press F9. See here. Similarly, let me just make it zoom out till one more time. Let me just press F9. Now see, again it is fitting into the screen. So whether your model is completely zoomed in or completely zoomed out, still you will be able to fit into your screen graphics area window by just pressing this F9. Okay. So this is one advantage. And then you have F10, 11 and 12. Okay. Now, let me press F12. Okay. Let me press F11. See, F11 is actually, okay. I'll tell you these options also. Let me press F10. See, F10 gives the isometric view. F10 gives the isometric view. So whatever component you have, the component will be presented in the isometric view format. You can see here on the right top corner, all your X, Y, and Z options are available, right? Which means this is the isometric view of the current component which you are dealing out. Okay. So which you can actually do it using your F10 option. Okay. Then you have two more options which are left out, which is F11 and F12. Okay. See, this F12, if you press once I can see my database is opening, right? On the left hand side,
Yes.
F12. So
Yeah.
if you don't want your database, because while working out, you want your graphics area window to be larger so that it makes your work much easier. Okay. So in that case, one more time, you can press F12. So this is a shortcut key to bring back your database, and you can remove your database as well using your F12. Then you have F11 option. Okay. So which is a very important option actually. So you need to do some kind of work using this F11 option. See, when I press F11, I think I have already taken what is the mesh quality check parameters which you will generally do for 2D meshing. So 2D comes under the shells. You can see here shells. Under shells, these are all the different mesh quality parameters which you will check it out. Okay. So if you bring your cursor to the particular mesh quality parameter, like for example aspect ratio, you have been given with the definition, and this is belonging to Nastron deck. See, ANSA actually uses Nastron deck as your default thing. And if you want, you can use some other deck also. The thing is, Nastron itself is a analysis software. So ANSA actually uses their options to, have the built-in function as per what is being used in Nastron. So the thing is, if I am just bringing my mouse pointer nearer to aspect ratio, I can see what is aspect ratio. See here, aspect ratio, I can say that it is applicable for quad elements because you are now seeing on the screen about the quad element, right? You have two dimensions, A and B in that, okay? And visibly you can say that your A is much larger when compared to B, right? Your length of A dimension is very large when compared to B dimension, correct? Shanti? Hello?
Yeah. Yes, sir. I'm listening.
Oh, okay, so fine. So this aspect ratio is nothing but the ratio. Ratio means you have a numerator term and a denominator term. So on the numerator, you have
Okay.
the maximum length, which is A, and denominator, you have the minimum length B. Now, if you once click this aspect ratio, you can actually change this value. See, the thing is now it has been defaultly set as the value 3. So after
Okay.
doing your work, you can simply press this F11 button to come here and then tick on what are all the parameters you need to check. So generally, these are all the maximum available parameters which you can actually check for quality check for any mesh. Okay. So according to your company and your client, whatever he specifies, accordingly you can check those parameters. Okay. So once when the meshing is
Okay.
done, you have to come here and you have to select those options, and they themselves would give you the values. Say for example, if the aspect ratio is 3, then it means that anything lesser than 3, 2.999 will be passed. And anything equal to that
Okay.
value or more than that will actually get failed. Okay. So these are all the
Okay.
different things which are actually available. Okay. So whatever check parameters you want to check it out, you can actually, select all these things. Okay. And similarly, you can also bring your mouse pointer to each and every parameter, and then try to figure out what are all the things which are actually being given as the definition. That won't be asked in the interview, but yet at least the value should be familiar. And already I have explained you about all these things using the PDF. You can go through that also. And all these
Right.
have been given with the colors also, like aspect ratio in terms of yellow color, green color, these for identification. Now, suppose instead of 2D meshing, if you are proceeding with any volume mesh like 3D mesh, then you can simply switch over your tab, solids tab. There also you have for solid mesh you have variety of mesh quality parameters to be checked. So whatever parameter you want to check and whatever values you want to fix, you can enter, and then you can actually try to find out which are all the elements getting passed and which are all the elements getting failed. Then then the next option which is available is the graph parameters. See, parameters is a parameter option by which you can actually change the color of the the quality check parameters which you have seen. Already you have seen that in shells, aspect ratio has been assigned with yellow color. Suppose if you want to change that, then you can come here. Most probably no one will come here because they will use the default color itself, because they want the values alone and their mesh to be proper, not rather than concentrating much on the colors. Okay. Then
Okay.
you have the presentation parameters. Here also there is no job for you. Okay, presentation parameters is something like the visibility and other kind of stuffs which has been shown here. Okay, so these two options are very important, shell and solid mesh. So these options comes through that F11 command, which you can make use of it. Okay, then
Okay.
so we have seen all those shortcut keyboards and then mouse pointer options. Now let me just go for F12. So now I brought back my database. Okay, so in database you have this material, right? Under this material, I
Right.
have been given with the card image of Mat1. And this has also been followed in the Nastron deck, and the same syntax word has been used here also. Okay. Now,
Okay.
if you just you can either double click this Mat1 material, or you can even use this also. You have also got a material tool button in your list option. Under the list option you have got the material button. You can make use of any
Right.
one of these things to check on how far the material, what material has been assigned for this. Okay, so this is a prime duty actually. So now let me just go for this material. Now, if I click that, then I'm getting this page. Okay, so where I can see that there are two different materials. Okay, but you know what? They have not been defined. They have been, each and every analysis software will take its own default material value. So you can see here that default material has been assigned for 1 as well as 2. And basically, if you have seen this, all these bolts will come under one category and the remaining part will come under one category, right? Both have the default
Right.
material assigned. They are not assigned exactly, because you can see that this box is unchecked. Only when you check
Right.
this box, then these materials will be assigned to this. Other than that, you will get error or warning messages. Okay, now let me just double click this default material Mat1. Now if you get inside that, then you can also rename this material. Okay, so generally ANSA software will take the default material as steel. And for this, they have created a material ID, unique ID, which is 1. See, this ID has been given. Suppose if you are dealing with, let's say, some 20 materials have been involved in your component. Okay. In that case, each and every thing has to be separated using this material ID. Okay. So that is the usefulness of the material ID. So material ID value is 1. And you can see the Young's modulus here, which is actually the Young's modulus value of the steel, structural steel. Okay. And if you have any doubt
Okay.
regarding any material Young's modulus, you can just Google it. Then you have the rigidity modulus. Just if you bring the cursor to it, then you will be able to see what is its definition and everything. And you also know that Young's modulus for any real material should be greater than 0, right? If you leave it as a blank section, let's say if you are going to make this as a blank section, and then if you are going to say okay, then the ANSA is not going to accept. See here, what is the thing which has been shown in the info tab? E and G fields may not both be blank or 0. It is an error. Okay, so you should not do those kind of stuffs. Other than that, you can enter whatever value you want. Okay, so this is there. So once again, let me just double click. Now see here, if I bring nearer to the G, it is showing me as shear modulus, or I can say rigidity modulus or modulus of rigidity. Again, this cannot be left blank. But the thing is, for you know about the material types like isotropic material, orthotrophic material, anisotropic material. Have you read about this in your undergraduate program?
Uh, yeah, vaguely I know, sir.
Okay, I'll tell you. See, if I say isotropic material, isotropic in the sense all the mechanical properties like elasticity, toughness, stiffness, all those mechanical properties along all the three uh, axes are one and the same. That is the meaning of isotropic material. if I say it
Okay.
is orthotropic material, out of the three perpendicular axes, any two perpendicular axes will have same mechanical properties, whereas the third one will be different. If I say it is an anisotropic material, then along all the three axes, all the mechanical properties are something different. Okay.
Okay.
We'll be dealing with mostly isotropic material. In that case, you have several material properties like Young's modulus, rigidity modulus, bulk modulus, Poisson's ratio, and density, right? You need at least two data to evaluate the entire thing. So in that case, you can see here your Young's modulus is being given and your new Poisson's ratio. If you just bring your cursor here, you are able to see Poisson's ratio value, right? For any real case, your Poisson's ratio should be between -1 to 0.5, right? Which you are seeing there as you bring your cursor nearer to nu. Okay, for steel it is 0.3, and rho stands for the density, mass density. Okay. So any two of this E, G, nu should be known so that the other things will be auto calculated by the software itself. Okay, this E raised power minus 9 is nothing but 7.85 into 10 power minus 9. Okay. This e raised power minus 9
You mean
means
10
it's
hours?
10 power minus 9. 10 power minus 9. Yeah.
Okay.
If it is
Okay.
10 square, it is 100,
So,
right? 10 cube it is 1000, right? In the same way, in the negative
yeah.
sense, 10 power minus 9.
Right. Okay. Okay.
Then
So
you have,
this, what are the list here? MATT1, MAT45, those are also different materials?
which one? Let me come that. Let me come for that. Okay. Now, as
Okay.
far as this particular part is considered, you have default mat1 material which has been assigned, right? Okay, let me just finish off all
Okay.
these things quickly. Let me bring the cursor to this A point, which shows that it is a thermal expansion coefficient. You might have learned in the form of alpha,
Yes.
thermal coefficient of expansion. You know, each and every metal has
Yes.
its own way of expanding or contracting either by increasing your heat or decreasing your heat, right? So that
Okay.
value you can specify it over here if it is required. If you are going to do some thermal analysis, then definitely this is required. Then similarly, if you have not given the value over here, but still you are going to perform the thermal analysis with, then definitely error will be shown. Similarly, you have the reference
Okay.
temperature. Suppose if you are doing some thermal analysis with some reference temperature, then you need to come here inside and enter here. Then what is GE? It is the structural element damping coefficient. In case of vibration analysis, modal analysis, you can actually make use of all these things. Then if I bring it over here, ST, it is the stress limit for tension, compression, and shear. These are optionally being supplied when you are going to do some structural analysis. But right now we are focusing only on the meshing part and geometry cleanup, where we are not going to do some analysis work. But if you are doing some analysis work, then definitely you have to mention what is the materials Young's model, materials yield point stress value for tension, compression, and shear. These are all the three other options which are available. Then coming to your point, it is MAT 1. This is a separate card. See, there are lots of cards which are available. Okay. Mat one is a basic material card which is actually definitely should be, given for any kind of geometry cleanup or meshing or analysis. But all these are optional cards. Suppose if you are doing a particular analysis, then you have to enable this and then give your values. I'll explain you once when we require these kind of things. Okay. So these are all the other options which are available. Similarly, you can double click this bolt material also, and it has been also assigned with the default material. And if you need to rename it and change the values, you can definitely do so. And once when you close it, it will ask whether these saved changes has to be applied to that particular component. And if you say yes, definitely it will be applied, which means that particular component will take only these values of X modulus, rigidity modulus, and Poisson's ratio and density. Okay. So these are all the
Okay.
different options which are available regarding the material. Now, similarly, you can also get into the properties. Okay, so you can see that P shell, it is actually a 2D thing. So P shell is a property which has been given and it has been opened over here itself. Okay, it has been given with the bolts have been given with some property ID, and then parent geometry. Other than the bolts have been given with some property ID. So you can check all these things, and all these things are actually very important. Okay. you can also click here so that you can see the type of the bolts and parent geometry, what type of elements have been assigned to that, everything you will be able to see. Okay. Then as I said that, see, in the material, you should definitely make sure that this has been assigned. Then only it will take that Young's modulus value or some material. Okay, if this is unchecked means it is not at all been given with any kind of material. Okay, so properties and materials, you should always make a check out of it, because I'll now tell you, see, once when you actually come into the geometry cleanup part, the first thing what you look for it is see, you have several surfaces here. The mouse pointer which I am placing it is a surface, and this is a separate surface. And similarly, you have this as a separate surface. So you have several surfaces, but these surfaces have been joined using something called as cons, which means I can say that if the surfaces are actually being joined using something called as cons. Cons are nothing but you can treat it as edges. Okay. Cons are
Okay.
treated as something like edges. Okay. Now,
Okay.
I have a doubt whether this bright yellow color and this gray color surfaces are stitched properly or not. Which means this component would have been modeled using SolidWorks, Creo, or CATIA. But the thing is, there you might find that these two components, these two surfaces have been completely attached properly. But that works on a different graphic standards, and this analysis software works on a different graphic standard. So once when you bring that component over here and do it, then I might actually have to check whether these two surfaces have been properly stitched together or not. Similarly, you have all these stitches which you have to check it out. So in order to check out for the geometry cleanup, you have something called as checks manager, which is actually available under this option tools. So if you just get inside the tools, you have checks. Under that, you have the checks manager. Okay. So in the checks manager, you can actually, select what are all the things which you need to check. Okay. So these are all the default options which have been checked in, and there are few options which are unchecked. Okay. So based upon what you want, you can actually try to check. And for the selected options, you can actually try to execute it. And see here, it is now showing me 100%. There is no warnings or errors, and status is showing as green color. So for all these parameters have been checked on the geometry. So this is the basic first step for any geometry cleanup. And you can also do the same thing like this. So you can go here for the checks, and then here you see something called as geometry. You can get inside this. And see
Okay.
here you have got a few more options which are present. Okay. Now, default, it will take the component which is being displayed in the graphics window, and then still you can actually try to execute it. Now, again, I can see that there are some warnings and errors where I can see that I have some triple cons issue, right? Can you see this?
Yes.
Triple cons. Okay, so basically you have three types of cons: single cons, double cons, and triple cons. So regarding meshing, before even getting inside the meshing, we have to do the geometry cleanup. In that geometry cleanup, the first step is to remove the unwanted single cons and triple cons. We need only double cons. Okay, let me show you. Can you see the
Excuse
yellow
me, sir.
color? Yeah.
Can you explain what single, double, and triple
Yeah,
cons? I
I'm
didn't understand that.
yeah,
What we
I'm
ah
going to. So if
okay.
two surfaces are joined using, if two surfaces are joined, then definitely there will be a double con.
Okay.
If there is a single surface with a single edge, which is not at all been attached to any other surface, then you will see the single con.
Okay.
If there are some three or more surfaces which are combined together and attached, then there will be a triple con.
Okay.
Now see here under the draw option. Now can you see here in the mouse pointer, single,
Yes.
double,
Right.
and triple. So the visibility option is also been given here for the user sake. Like for single con, it would be red color. Let
Right.
me just press this single con, so I don't find anything. Okay. Now if I see, now I have removed the double cons, and you can see nothing is been visibly present over there in the graphics window. Now let me once again check for the double cons. If I press that, all the double cons will be visibly seen in the graphics window. Can you see here? But once
Yes.
when I disable this, I will not be able to see. Our aim in the geometry cleanup is to keep the double cons alone. Okay, we don't want the triple cons. If that is the case, then we have to modify that, and we don't want the single cons also. Now, in order to show you the triple con, that will be actually in the cyan or blue color. Okay, right now we don't have any triple con in this component, I think so. Okay, sorry, we have, but it is not been shown properly, right? Because in the just now we have checked for the geometry checkup, no, using the check managers geometry option,
Yes.
where we have some triple con issues. Okay, that issue I'll tell you how to sort it out. Okay, now in order to show you the single con, let me just do something. Let in the faces option, let me select the delete option. Let me select this face. Let me just delete it. Now can you see the single con?
Yes.
Which means that it is that surface is not attached to any other surface, and it has been left out with a free edge. That is nothing but your single con.
Okay.
So just to show you, I'm just just showing this. See, you can do the undo option and then bring back
Okay.
whatever you have did. Okay, so you can also check out with the component because you already might have the component with you. Okay, now
Okay.
then one more thing which you have to know is, see, while selecting this, let's say, for example, I'm going to apply the OR Boolean operation. You usually generally try to select it like this, right?
Right.
Okay, fine. Now let me just invert it back. But the thing is, you are able to see some cross symbol, right? Here,
Yes.
cross hatches. So if I just enable this, you will be able to see the cross hatches. Can you see it here? Two green color
Yes.
dotted
Yeah.
lines crossing each other. This actually
Yeah.
makes the selection very much easier and better. I'm not saying that you should definitely enable this option for selecting any surfaces, but if you enable this option, the selection becomes very easier. Okay. So
Okay.
once when you are particularly dealing with any 2D option, definitely, please try to follow this because that is very important. Then so the single cons and the triple cons are the one which are actually going to make your meshing a problematic one. So you should make sure that everywhere you have only the double cons. Okay.
Okay.
Now, once when you actually in the next session, we'll be seeing about something called as the topo module. Already we are into the topo module only. Under that, we'll be using these options. Okay, and these are actually very very important since you after performing all these options only, you'll be able to remove the unwanted triple cons and everything. Okay, because once when when you do that only, then you can proceed on with your next step. Okay.
Okay.
Then you also have hot points. Okay, so these are called as hot points. Can you see the option under the topo module as hot points?
Yes.
And see here, there is a con which actually separates these two surfaces, right?
Right.
Surface and this surface has been separated by this con. And you have that hot points, which is nothing but the two corner points. So in general, I can say cons as edges, and you know about the meaning of surfaces, and along that edge you might have some hot points. These hot points you have default within the component itself. Now you can see here also you have got two hot points here and here in the circular portion. Now using these hot points, you can directly insert a line to cut it as several more surfaces if you want. I know in that case to case, it will differ. Why you want different surfaces? In that scenario, I'll just try to explain. But these hot points are generally used to to connect or draw a line in between and then make it as a two different surfaces. And suppose if you don't have any hot points, let's say for example, you have hot points here naturally present in the component, but let's say that you want to separate it over here, then you can insert also. You can insert the hot points also. So insert a hot point on a cons or a node on a curve. Okay. So whenever and wherever, according to your scenario, you want to differentiate or you want to separate two surfaces, then definitely you can make use of this hot point option. Okay. So try all these things and try to work out, and I'll share this video. And in the next class, we'll be entering into the geometry setup. But for the first step of geometry cleanup, we have to get into the checks geometry manager, and then we have to check for the basic criterias. Okay, and if possible, according to your company or client, they might actually tell you what are all the things which you have to generally check for any geometry cleanup. So those things have to be checked out, and that will give you a warning message like triple cons are present, single cons are present. Then you have to isolate those particular things and then try to convert that particular single cons and triple cons into double cons. Because once when you do the double cons only, that particular component is fit enough to get meshed. Okay.
Okay.
We'll
So
continue.
we'll always be the checks when we are given a component like this, they will always tell us these are the things you have to check for, or is there like a
Yes,
set
yes.
that we
But yes,
always
exactly.
check?
Yes, exactly. See here, I'm getting into the geometry part here, and then you have got options here.
Right. So we have to check
Oh,
for all
single
of
cons
this,
is
or
unchecked, but
right.
you can check it. And you can also
So
check for sharp
always
edges. That's what I'm saying. These parameters, which one has to be checked in, which one has to be checked out, generally will be determined according to the company you work in. Okay. But I'm saying default, there will be few things which will be checked in, like sharp edges, because we generally avoid sharp edges. Already have explained you where the meshing becomes difficult. And see here, collapsed cons, mostly related to cons, everything will be default checked in any software, like triple cons, overlapped faces, cracks, single cons. All these things are generally checked in. Okay. Once when you check in all this, then you can execute, and then it will show you the errors. To look on for the errors, you can actually right click, and you have options like show and show only. So if I say show only, then that particular part alone will be displayed. I'm just pressing F9. You know what is F9? Refit. So this part alone is being shown here, and that is the only part which has been connected with that error. Similarly, the same error with the same part. Okay. Similarly, you can check it out. You have got all these things. Okay. So you need to remove all these things. Now let me show you the triple con. See here, it is not showing because we have not checked in this triple. Let me just now. Can you see the cyan color?
Yes.
Blue color. That is the triple con, which we need to remove. Then only that error will actually go. But don't ask me a question
So,
that, sir, can we check out that box of triple cons so that only this is showing error? No, that is not the case. Triple cons generally we avoid for any kind of machine. Okay.
okay.
Yeah, tell
So
me.
the triple con is there because there are three surfaces, or
Yeah. But you know what? Where the triple con is present, that alone has been isolated now because I have given the option show only.
okay,
Because if I have the entire model, then it's very difficult for me to figure it out, right? If I
right?
say, if I
Yeah,
select
that's
show
correct.
only, then only I'll be able to figure out properly where the triple con is exactly present. Okay.
Okay.
So in this way, you
And so
can
what
actually
is the
check for the
reason
errors. Yeah, tell me.
we don't I mean what's wrong with having triple cons in the component
See,
if there
triple
are three
cons
surfaces?
is actually like, it is a temporary con, or I can say that it is a con which has been formed by, by joining of three or more surfaces, where you might have two cons at the same place itself. That's why it is called triple con. So triple con is the one which we have to avoid. Okay, so we have to convert that triple con into a double con. Using that hard points option and cut option, we can separate it into two surfaces and make it as a two double cons also. Then only we'll be able to mesh. Okay.
Right. So there isn't actually three surfaces, but it
Yeah.
shows as a triple con.
Since I have shown only show
Is that
only option, it is exactly showing where that triple con is present. Okay.
okay?
Okay. Try this out and we'll continue tomorrow.
Okay, sir. So what time tomorrow, sir?
8:30.
Okay, sir.
Okay.
Okay, thank you. Good night.
Thank you.